Alright, 1.4 geometric series. This is number 2 because the first recording of this one was horrible. So, a geometric series, by definition, is the expression of the sum of the terms of a geometric sequence. Oops, that should be of the terms of a geometric sequence. So you're taking a geometric sequence which has that ratio, that common ratio between the terms, and the commas in between the terms, and you are adding them together. So that's the difference between the series and the sequence. Sequence has the commas, and the series has the plus signs in between. So it says, one example of a geometric series is a phone tree. Suppose the school band constructed a phone tree. Draw the first 4 levels of the tree below. So we would start with the first person. They would call 2 people. Those 2 people would each call 2 people. And then the next 2 people would, in turn, call 2 people. Oops. So we have our first 4 levels. We started with 1 person, we went to 2, we went to 4, we went to 8. So then the pattern that we're developing is that we're going 1, 2, 4, 8. So we're doubling every time. So it says that notice that each level is a term in a geometric sequence. What is the common ratio of the sequence? So it's a 2. If you divided term 3 by term 2, you'd find that 2 is your common ratio. Other than listing each term in an addition statement to find the sum of the terms, we can develop a formula to calculate a geometric series. So it says the series above is the sum of 4 numbers. So we have 1 plus 2 plus 4 plus 8, so we'll call that equation 1. If we multiply each term in the series by the common ratio, which in this case is 2. So if I take 2 times sum of 4 is equal to 1 plus 2 plus 4 plus 8, we'd end up with 2 times sum of 4 is equal to 2, 4, 8, 16. So we're going to call that equation 2. If we were to subtract equation 1 from equation 2, so equation 2 is 2 times the sum of 4 is equal to 2, 4, 8, 16, minus equation 1, which was sum of 4 is equal to 1 plus 2 plus 4 plus 8. So we line them up. So if we subtract, in essence, this is a 0 here, and this is a 0 here. So if we subtract each one of these terms, I have 0 take away 1 is negative 1, 2 take away 2 is 0, 4 take away 4 is 0, 8 take away 8 is 0, and 16 take away 0 is 16. So we have 2 minus 1, because that's where I'm taking 2, take away 1 here. S4 is equal to negative 1 plus 16, so that would be my 15 there. So if I isolate my S4, that means I would have to divide each side by 2 minus 1. So if I divide this side by 2 minus 1, I divide that side by 2 minus 1. So 16 minus 1 over 2 minus 1 is just equal to 15. So if I look back here at my phone tree, if I count up these, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So by doing these 2 little equations here, I was able to come up with how many without actually counting them. So all I did is I multiplied each by I multiplied my original series by my common ratio, and then solved for sum. So it says you can use the method from here to develop a general formula for the sum of a geometric series. So a general statement is the sum of the numbers is equal to term 1 plus term 1 times the ratio plus term 1 times the ratio squared plus term 1 times the ratio cubed plus, and then so on and so on and so on. Because if I look here, I started at term 1, which was 2, That's term 1 times the ratio, so 2 times my ratio of 2 gave me 4. Then if I went 2 times to get to 8 here, times 2 squared, that gave me 4 times 2 is 8, and then my next term would have been times 2 cubed, which would be 8 times 2 is 16. So I can continue going on with that till I get to t1 times r to the n minus 1, so till I get to my last term. So we could continue with this pattern, and I'm not going to go through the whole pattern. If you want to see how this formula is developed, then you can just read it in your textbook, and it's approximately, I want to say, about page 49. So by going through the steps and reducing what we have, we get the sum formula. And the sum formula is you take the first term and you multiply it by whatever our ratio is to the number of terms minus 1 over your ratio minus 1. And your ratio cannot be equal to 1. So if your ratio is equal to 1, you can't have this because you'd have 1 minus 1 in your denominator, and you won't have a geometric series. So this is our one way of doing it. The other way of doing it, so this is when you're given your first term and your ratio and your number of terms. So you need to have those three things. So T1 is your first term. That's the same as the A that we were talking about in the other sections. N is however many terms you have, and R is your common ratio. So if you have those three things, first term, the number of terms, and the ratio, then you can use this sum formula. If you don't, then you use this formula. And this formula, how they derived it, is on page 51 of your textbook. So if you want to know how they came up with that formula, then just read through that section of it. You don't need to know how they came up with it, so I'm not going through those steps. But if you are not given number of terms, then this is the formula you use. It's the sum of the numbers is equal to your ratio times your first or your last term or your nth term minus your first term all over your ratio minus your first term. So R is your ratio, Tn is your last term or your nth term. So if we're talking the 17th term, then it would be whatever the 17th term is, minus your first term divided by R minus 1. So the first example says, determine the sum of the first 8 terms of the following geometric series. So A, we have 5 plus 15 plus 45 plus so on. So first thing we always do is we identify our variables. So T1 for this is equal to 5. My R is equal to 15 divided by 5, so that's 3. My N told me that there was 8 terms. So this one has told me my T1, my R, and my N, so I can use just my regular sum formula. So sum of the numbers is equal to T1 times R to the N minus 1 all over R minus 1. So the sum of my 8 numbers is 5 times 3 to the power of 8 minus 1 all over 3 minus 1, so all over 2. So this is equal to 5 times 6,560 over 2. So my sum is equal to 16,400. So B, term 1 is 64. They've told me my common ratio is 1/4, and I know my N is equal to 8. So for B, if I substitute these in, I have 64 times 1/4 to the power of 8. I'm just going to put a square bracket there. Minus 1 all over 1/4 minus 1. So Remember when you are doing a fraction to the power, the power applies to the numerator and to the denominator. So this is 1 over 65,536 minus 1. And this is over -3/4. So 1 minus 65,536 minus 65,536 over 65,536. Whoops, that's not supposed to be a plus. Divided by -3/4. And I'm going to write it that way so that you can do the flip and calculate. So when I multiply, this is 64 times -65535 over 65536 times -4 over 3. So this, when you do your math, if you multiply 64 times -65535, divide it by 65,536, times it by 4, divide it by 3, you get 85.332. Okay, the next example, it says determine the sum of the following geometric series. So I have 1 over 64 plus 1/16 plus 1/4 plus all the way up to 1024. So if I look at this one, for my A here, my term 1 is equal to 1 over 64. My ratio is equal to, I'll do 1/4 divided by 1 over 16, so that's the same as 1/4 times 16 over 1, so that is equal to 4. I don't know my number of terms. So because I don't know my number of terms, I can't use that regular formula, so I have to use the other formula that I gave you. So I have to use this one. R times the nth term minus T1, so minus the first term over R minus 1. So I do know that my last term is 1024. So the sum of my numbers is equal to 4 times 1024 minus 1 over 64 all over 4 minus 1 is 3. So this is equal to 4096 minus 0.015625 all over 3. So your final answer is 1365.328. Okay, so B. I know my first term is -2. My R is equal to 4 divided by -2, so it's -2. And my last term is -8192. So my formula, R times the nth term minus the first term all over R minus 1. So I have -2 times -8192 minus -2 all over -2 minus 3, or minus 1 is -3. So my top is equal to let me see where 1,638,412 divided by -3, so it equals -5,462. Next one says example, a Scrabble tournament with 512 players is held. When a player loses, he or she is eliminated. The winners continue to play until a final match determines the champion. What is the total number of matches that will be played in the tournament? So we know that every single match has 2 players. So that means, to calculate my first term, that would be the first match. So I would have 512 people playing, but there's 2 people per game. So that means that there would be 256 matches at the very first round. So if there's 256 matches in the first round, then in the second round, you'll have a winner and a loser. So then half of those people are going to be eliminated. So that would mean my term 2 is going to be 256 divided by 2, so 128 matches in the second round. So if I set this up as a series, my first number is going to be 256 plus my second number plus all the way down till I get to the finals, and in the final there is one match that determines the winner and the loser of the whole thing, or first and second. So right down to one final match. So if I'm looking at this, I know my T1 is 256. I know my last term is 1, and I know my ratio because I'm always dividing by 2, so my ratio is 1/2. So I use that second formula. So my ratio is 1/2 times my last term was 1 minus 256 all over 1/2 minus 1. So 1/2 minus 256 is negative 255.5 all over negative 0.5. So that equals 511. So there would be 511 matches played all together. So that is the end of geometric series. As you can see, the formulas are kind of similar to what we were doing in the last section. You just need to keep in mind whether you have the number of terms or not. And if you have the number of terms, you use the first formula. And if you don't, then you use this formula.